Yeah, in this video, we're going to talk about how to use software to do analysis for project scheduling, which is chapter 13 in your textbook and the last topic. So it assumes you have studied this chapter, and if you have noticed, there are no web files for this class. Instead, I posted all these software on your Blackboard. So if I want to use this one to show you how to use this one, it's very simple. So if you click on it, go there and you download. It's called MS60. It's a software that's really done by the primary authors of your textbook. It's an old one, but it's very simple to use. It has also other pieces that you can use for other components of the course. So you download, and once you download, you will have it on your computer. Something, it will appear like this wherever. You can put it in your desktop or anywhere else. You click on it and you will see this, the management scientist. You click continue, and you can see here there's linear programming, so you can use linear programming with this, integer programming. You can have waiting lines, decision analysis, forecasting. So these are simple, easy to use software. They don't need quite a bit, anything, but also the output is not sophisticated. So I'm going to click on PERTCPM. That's for project scheduling. It's PERTCPM, and then click OK. And you notice here you have up to 25 activities you can use, and I want to click new or open. So if I go to file, I can use either one. I want to do a new file. I want to do two quick examples, same problem. First with known activity times, then with uncertain activity times. I want to do the example in the class notes I have on Blackboard. So it has 6 activities, and so you just click OK, and you have this page here where it's very simple. You just start by selecting activity A and the time I have. So let me go and see. This is the problem that if you look in your class notes, that would be 1. So that's 1 day. And click return, it goes up there. So if I go to B, B does have A as a predecessor, so I click on this. Its time is 3. Oops. If I go to C, that also has A as its predecessor activity, and it has 7. Go to D. D has C as its predecessor, and it has 4. E has B as its predecessor, and then has 9 as expected length time. And I have to go to F. F has D and has E, and it takes 1 day. And then I go say solution, solve, okay, and boom, that's your output. You get the activities, you get the earliest start time, latest start time, earliest finish, latest finish. You get the slack and the critical activities, because activities with 0 slack are on the critical activity, and that's your critical path A, B, E, F, and the project completion time is 14 days. Okay. So let's go back and do the same activity now. I'm going to do another one, new. Yes, and I want now uncertain times. I still have the same number of activities, 6. Okay, and you can see here I have activity A. I need the optimistic, the least amount of time it takes. And if you go to around, I think it's on page 7 and the class notes, you will see those numbers. It's 0.8. That's what I have here. I have 1 here. I have I think 1.2. So if I go to activity B, again its predecessor is A, and I want those numbers now. It's 2.4. The next one is 3 and 3.6, and I go to activity C. C has A, and I want 5.6, 7, and 8.4. See, okay. D, I have predecessor of D is C, and I have the most 3.2 as the most optimistic for the most probable, and 4.8 as the most pessimistic. Go to E, has B, we did that, and if you notice that the most probable are the same times as in the previous example. So here we have 7.2, I have 9, I have 10.8, and I have the last one, which has D and E, and I have 1.2 and 1. But oh no, I think I got those wrong. This should be. Yeah, it's telling me that, of course, because I'm gonna change. Oh, it's not letting me change that, but these numbers are not correct. So this should be 1.2. This should be 1, and this should be 0.8. Now I'm done. I can go and click on solution, solve, and this is my output. So I have my activities, their expected time, which happens to be the mean time. In this case, because I picked the optimistic and the pessimistic to be symmetric around the mean, so that's the same as the mean are the same as the most likely, but it doesn't have to. And I have the variance for each activity, and have, in this case here, have the activities, the earliest start, latest start, earliest finish, latest finish, the slack, and the critical activities. And you have the critical path, the expected now project completion time is 14. The variance of the project completion time is 0.41. So that's the variance for the critical path, where you can add the variances in here. So you don't want to work with standard deviations until the end, because you can add variances, you can't add standard deviations. Okay, and that's how to use this software, and thank you.